Here we are looking at Target 1A from our Chapter 5 study guide. We're asked to simplify the expressions using some properties with exponents. Now, in just looking at our problem, we see that we have this entire base raised to that fifth power. So again, this entire set is inside of the parentheses, and that's all being raised to that fifth power. Now, as a result, we can look at this negative 5, and we see that his exponent is actually not x. It is, in fact, 1. So this negative 5 is being raised to the first power. If it's not written there, it's always assumed that it's 1. And it's being multiplied by the x squared, y to the negative 5th, and z raised to the negative 7th. Now there's a variety of ways that we can go ahead and proceed with this one. I think what we'll do for this particular problem is we'll just do the power to the power. I think also maybe I'll just show the other way though that you can do it too. Just so you guys get a diverse, set, and you can kind of pick what you want to use. So because we have this negative 5 raised to the first is being raised to the fifth power, we would multiply, because again, that's power to a power, that's that property. So we have negative 5 as our base, raised to the 1 times 5. So 1 times 5. Now for our x, it's the same thing. We have x squared, that power raised to a power. So we would be multiplying that power. So 2 times 5. For y, it's exactly the same thing. All of these exponents are going to be being multiplied when we distribute the 5. So we have negative 5 times 5. Then for z, negative 7 times 5. So again, that's just our power to a power being raised to all of that fifth power. So when we do this, we have negative 5 raised to the 1 times 5 is 5 as that exponent. For x, we have it raised to the 10th. For y, we have it raised to the negative 25th. For z, we have it raised to the negative 35th. And now we can go ahead and place our exponents where they appropriately belong. So because our y has a negative exponent and so does our z, we're going to go ahead and throw those on the bottom. So when we do that, we have negative 5 raised to the fifth power, x to the 10th power, all over y raised to the positive 25th exponent, z raised to the positive 35th exponent. Now when we're looking at 5 to the 5th, we should really simplify that number up. So we would end up then with 5 times 5 is 25, times 5 again, that's 125, times 5, that's 625. And so then 625 times 5. Let's see here, we get 25, 2, 10, 12. 3125. We get negative 3125 x to the 10th over y to the 25th z to the 35th. So again, that is one method that you could take in solving for this one. The other method we've talked about from class as well is pretty much where you just start out by placing their negative exponents where they appropriately belong. So for example, this y raised to the negative 5th and z raised to the negative 7th, we're going to go ahead and place those on the bottom right away. So when we do that, we end up with negative 5 raised to the first, x raised to the second, all over y raised to the positive 5th, z raised to the positive 7th. So again, just placing those negative exponents where they appropriately belong, in this case on the bottom. And we should keep in mind that this is all still raised to that fifth exponent. So again, inside the parentheses, all we did was place those negative exponents where they appropriately belong. And at this point, now you can go ahead and do your power to a power. So pretty much just distributing that 5 in to all of those items. So when you do that, you should end up then with the exact same thing, negative 3125 x to the 10th all over y 5 times 5, 25, z raised to the 35th. So 2 different routes to take, same exact answer though. Again though, that is target 1A from our Chapter 5 study guide.